In this video, we'll continue with our series on complex numbers, and we will have two examples on factoring using complex numbers. So let's say we have w to the power of 4 minus 1, and we want to factor that expression. So we can notice that this is a difference of two squares. So when I factor, I have w squared minus 1 times w squared plus 1. And we notice that our first set of brackets is still a difference of two squares, which can factor to w plus 1 times w minus 1. But we are left with w squared plus 1, which normally we cannot factorize. But what I can do is rewrite this expression to also be a difference of two squares. And how I do that is I rewrite plus 1 as negative I squared, where I is the imaginary number of the square root of negative 1, and I squared would be equal to negative 1. So if I rewrite plus 1 as negative I squared, it's the same as saying negative times negative 1, which is simply plus 1. So if we continue factoring, we will have w plus 1 times w minus 1 as our second pair of brackets times w squared minus I squared, which is a difference of two squares. So our final answer would be w plus 1 times w minus 1 times w minus I times w plus I. And now we have completely factored the expression of w to the power of 4 minus 1. Now let us look at a second example. Let's say we have w to the power of 4 minus 4w squared minus 5. Now if I consider this to be a normal trinomial, I notice that I can use the factors of 5 to create our middle term of negative 4. So when I factor that trinomial, I'll have w squared plus 1 times w squared minus 5. So when I expand these brackets, it will lead back to my original expression. And now I notice again that I have w squared plus 1, which I can rewrite to be a difference of two squares as we did in our previous example. Also, we have w squared minus 5. Now normally you would think you cannot factor more, but let us focus on our first set of brackets, which will factor into w minus I times w plus I. And our second set of brackets would factor into w minus the square root of 5 times w plus the square root of 5. So if I expand the first two sets of brackets, that will lead to w squared minus I squared, where negative I squared is equals to plus 1. And if I expand the second set of brackets, that will lead to w squared minus 5. So now we have completely factored this expression.